This is Lynn.
We are going to show you how to solve a rational inequality algebraically. And this is round 2 for us because we forgot to turn the audio on the first one. So here we go. Let's see if we make no mistakes.
This so fast.
Yes.
Okay, so we're going to start off and we're going to move our inequality over to one side. Oh.
Right. Because I find it a hard time thinking of the number being greater than or equal to a function. I like to think of a function bigger than or equal to a value. So here we're going to have this function on the left-hand side bigger than or equal to 0, so positive. All right, so we need to get a common denominator for all of that.
What's so fancy about this is this will factor to x times quantity x plus 2. So if I change that, this stays the same.
All right.
Once I change this function, oops,
Yeah.
then I will go ahead and multiply it by x plus 2.
Right. And so this is pretty heavy algebra we're working on through here. Make sure you don't mess any of your signs up. And this one we're just going to multiply by the entire denominator, top and bottom.
That's why it's nice to have two people do this, because then you typically don't make mistakes.
Right. Okay.
Simplify.
So the bottom is still the same. And I like keeping it in factored form. It keeps it easy to work with.
Beautiful.
So I get 1 plus, if I FOIL in my head, I get x squared plus x minus 2.
Minus, let's make sure to keep this all in parentheses, just to keep everything neat.
Right, because we have to subtract that whole function, so all those signs.
How often do you forget that negative right there, you know?
Too often.
Man, that just messes you right on up.
Exactly. Okay, so now we got to collect like terms, put it together.
Denominator stays the same.
Yeah. We look at the
numerator.
If we look at the top, we get the x squared minus the x squared, so they vanish.
Done.
And the x's, I get x minus 2x.
Don't forget that minus.
Right.
Boy, that's a tricky guy.
It is. So minus x.
Then we have 1 minus 2 minus 1.
And
greater than or equal to?
0. Okay. And so now we have to consider when the function is going to be positive, meaning bigger than or equal to 0. And there's several turning points or like breaks in the graph. And so we have to find the x-intercepts and the vertical asymptotes, which means we set the numerator equal to 0.
Or we can set the denominator, both actually.
Right.
So let's start off with the numerator equal to 0. Negative 1 minus 1 equals 0. That means I'm going to have at x equals
minus 1. Indeed. And that's our x-intercept. Top of the function is always equal to 0.
Then we'll do the bottom function equal to 0. This is easy to see because it's in factored form.
Right.
0 or
negative 2. Which on the graph are our vertical asymptotes.
So if we were to draw our sign chart here.
Love sign charts.
Minus 2, minus 1, 0. Before we go any further, we know something about when our denominator is equal to 0. So if x equals 0, we know that that function is undefined. So we can put a big open circle right there.
Meaning it's not part of the solution or the function even.
And when x is negative 2, also undefined. Big open circle there. What about x being equal to negative 1?
Right. Well, we know that that's an x-intercept, and we're looking for the graph being bigger than or equal to 0. So we're going to shade that one in because it's going to be part of our final solution.
Now all we have to worry about is points over here, over here, over here, and over here.
Right. Okay, so we have to do an analysis of those regions, and there's 2 ways to do it.
Let's see. So if we pick a point over here, such as x equals negative 5.
Okay. I put it into the top of the function, and I get negative 5, which is positive 5, minus 1, which is
minus 1
over negative 5
times negative 5 plus 2 is
negative 3.
So we can think of this as 4 over
15.
Yeah, thanks. I can't read my messy writing.
Right.
4 over 15. And we want to know, is that greater than or equal to 0?
Most definitely.
Yes. So we can put a yes here. Now, there's another way to do this.
Right. As opposed to actually doing the calculations, I just look at the positive or negatives, if it will be a positive or negative value. If I plug in negative 5, with a minus -5, that's a +5. Subtract 1, I know is going to be positive.
Big fat positive. So positive on top.
Yes.
In the denominator, since we have negative here, we have -5 here.
Right.
And inside our parentheses, -5 plus 2 is a negative. So if I have positive over a negative times a negative, that ends up being positive over positive, which is positive and greater than or equal to 0, which makes it yes again.
Right. Now, anytime through this podcast, you might want to pause and make sure you do these calculations for yourself.
Since we're getting a little messy here.
Right. So you might even want to pause now and try it for like -1.5 yourself and see if you get the same answers we get.
So you guys push pause. Try it for x to be -1.5. Come back to us in 1 second.
Okay, hopefully they're back. We don't have to pause.
I hope we get the same answer.
All right, here we go. So if I put -1.5.
So negative becomes a positive. 1.5 minus 1 is a positive on top.
Yes. And
On
on
the bottom.
the bottom I get negative, of course, the first factor. And then -0.5 plus 2 is a positive.
So our answer ends up being
Negative.
Is that greater than or equal to 0?
No.
Nope. Okay, over here.
The
let's
next
take
region.
0.5.
There we go. Negative. A negative
So
0.5.
Minus 1 is negative.
Yes, negative.
Okay, and the denominator?
We get
Positive.
this x should be -0.5, I think.
Ooh, bad. Little mistake there.
Yep. So it's
Which is going to change our answer up here.
at the top, I think it should be okay.
Let's see. Negative, minus 1, negative. Okay.
But this one's going to be negative. The first factor is negative. The second factor is also going to be positive. Not also, it's all by itself.
So negative divided by negative is positive. So is this whole function greater than or equal to 0?
Yes! Hooray! We should have sound effect of applause in the background.
Okay. Last one. Easy peasy is 1.
1. There we go. So negative is all negative on top.
Bottom, positive, and
Positive.
positive. Ends up being
Negative.
greater than or equal to 0?
No,
Nope.
no, no.
Now let's write this inequality.
So,
So if I'll just go ahead and draw this out just to make it clear because gosh, I'm messy.
so -2 to -1 to 0. That's cycled in.
And this is a yes.
Yep,
And this is yes.
right.
So how do we write this inequality?
Okay, well, we want to go x is less than -2.
Cannot be equal to.
Correct.
Union.
Union -1 less than or equal to
X, which is less than
0.
So another way to write this.
Is an interval notation.
So we could go, since x is less than -2, it can go all the way from -infinity, not including -2. So therefore we have
A round
round
bracket.
bracket, union. Now it includes -1,
Right.
so that's square bracket, -1, all the way to 0, not including
0.
union.
So there's two ways to write the answer. So that's your final answer, is that scenario there.
Yeah, either answer.
Works.
do.
Right. And if we look at the graph,
Go over here.
yeah, we can bring that down over.
Oh, I have it last.
Yep. You want to go to the, yeah, there we go. If we look at our graph, we can make it a little bit bigger.
Oh man.
All right, and so if we look at the graph, woo, all right, let's just stop. Go back. Let's just
We'll
keep
backspace
it.
that.
Oh, here we go.
There we go.
Here we go. Let's put it up here, and we'll slide it. Okay, so if we look at the graph, the function that we have the first part bigger than or equal to 1. And so here's my line y equals 1.
So we want to know where that function is greater than 1.
1. And so that's all of this part of the region here, and
Little
that
guy
little
right there.
part there.
But you have to think about it because you actually have to understand the graph in order to write your inequality.
Right, and one of the things I've been talking about in class is that x values are like vertical lines here. And I have to think about my x value. Let's see if I can get a vertical line that can work really nicely for me. So I have to, okay, if I take my vertical line now, I ask myself, as I move my vertical line across, is it touching 1 or above 1? And the answer is yes, 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 yes. Oh, no. So all these x values produce y's of bigger than 1. It stops, it's not existent, then it's no, 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 no. Oh, it touched the x of the y equal to 1 value. So it's yes, 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 yes. Oh, stop. And all of these are no, 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 no. So x values represent vertical lines to see what the y values are doing. And it gets tricky getting those two straight.
You have to remember your vertical asymptotes with the functions undefined.
Right. And so our final solution is x less than -2 union -1 less than or equal to x less than 0. And that is it. Are we good?
Oh, good. See you later.